All right, so we're back. Now we're going to talk about the last lessons in sports chapter 1, 1.5 through 1.10. As you can see, we're covering quite a bit of lessons here, but the reason we're able to do that is because the latter lessons in this are just a lot of review of what students have already done. So depending on how much of those activities I suggest you supplement with and how much time you took, you may or may not have time to go through these latter lessons, and that's okay, because if you took enough time at the beginning, they should have enough practice and knowledge of these concepts. And the last two, I'm sorry, well, basically almost the last two are dealing with something called projectile motion, which technically they're not going to be tested on. So, we'll talk about how to address that. But first, I do want to talk about a lesson that is going to introduce some new concepts to students, which is 1.5, acceleration. Now, instead of doing this with this accelerometer and having them set up, because these things kind of are not as intuitive for students to use and sometimes are hard to find or to get the materials to make, I like to approach this lesson a bit differently. I like to do it with some materials that I find are very easy to come by, which, a long piece of wood to make a ramp using a Matchbox or Hot Wheels car or a ball, though the ball can tend to roll off the ramp towards the middle, so the cars tend to stay a bit straighter. And I like to do acceleration lab using these materials, which are easily to come by, and students still, for some reason, at this age, like to play with Hot Wheels. So there you go. And if you Google it, there's a ton of resources out there at your disposal that has this lab set up with a procedure and the data tables for students. So very, very easy for as a teacher to access and use in their classroom. And kids again could use their phone as timers and get the time at kind of at the beginning and at the end of the track. So we can use that to get the starting velocity and final velocity. Of course, if you happen to be lucky enough to have photo gates, that's awesome. You'll get very precise data, but most schools may not have those. They tend to be kind of expensive. Plus, you need to know how to use them and have a computer and all that stuff to collect the data. So, kids could just use their phones, and you could just measure, the distances here, and use that to collect the data and find the speed or velocity, and use that to find acceleration. So again, the data and using the formula to calculate. Of course, students will need lots of practice, so you need to take a day or two, probably two or more, where they practice acceleration, because it is a change in velocity, and this may be new, finding a change. We did find change in temperature with students when we were talking about heat and calculating heat transfer. So that may be something to remind students of. Delta T, we did do this before. So now change in velocity, same thing. Final, take away the starting. And because, that's what acceleration is, a change in velocity. So we know how much it changed. So one important thing, I put it here in orange, is students, should be doing final first, take away starting. All right. So that, they always like to put the start in, take away final, because, most things we always have a start and then at the end, it just goes in order. But, for the calculation, actually final first, take away start. And so you're going to have to remind students of that. And as they're practicing, make sure they're doing that correctly. So lots of practice with this formula here. Take the time to go through that, because honestly, the next few lessons are review. So, if you've been taking your time to give them practice with the formulas beforehand, with the graphs, and now with acceleration, if you run out of time according to your pacing guide here, it's okay, because these next few lessons at the end from 1.6 on are mostly going to be review. For example, 1.6, this is just more graphing and speed calculation practice. So if you have time, you could do it, or you could just supplement more practice problems or more graphing. 1.7, increasing top speed. So this introduces like stride length and frequency. We talked about frequency in the previous unit with waves, trying to, I guess, relate frequency to running. But for students, it's not that easy of a relation, not that intuitive for them. I usually, skip this, supplement with more speed problems that type of thing. And then 1.8, 1.9. This is interesting. Projectile motion, which is a very important topic in physics. And this is what I was talking about at the beginning of this video. So here's 2 lessons on projectile motion. And any physics course obviously should cover this very important concept. However, our current standards and our testing with the MCAS, they don't cover this. They really don't cover projectile motion. So I find it to be a better use of my time not to do this with my 9th graders in a more upper level class. This will most likely be covered, but with my 9th grade intro physics class, I'm just not going to do projectile motion. So if you want to be diehard and go through these lessons, because you feel a physics course should, by all means do it. But I'm telling you, they're not going to be tested on it in 9th grade. They're just not going to see it. Okay, so save it for your upper level physics course, your AP physics course, if those are available at your school. The kids will get it then. And then finally, the last lesson, 1.10, energy, the pole vault. Interestingly enough, it goes back and, they start covering potential and kinetic energy and energy conservation again. So this activity, may prove useful as a review. I mean, it's relating it to the sport. So now it talks a little bit about the speed of the runner and how will that affect their pole vault, that sort of thing. So it puts in context of what they were doing, and it brings it back to potential and kinetic energy. So it is a nice review. Students, like I mentioned in those previous videos when we first discussed these topics of potential and kinetic energy conservation, it can be difficult for them to work these calculations. So maybe a good review and a good review of the concepts. One thing to note, though, is it does introduce the PE of a spring formula in that physics talk to read in there. And students don't need to actually use this formula. It's not even on the formula sheet, MCAS formula sheet. So, you could talk about the formula, but for some reason here in Massachusetts, they're not going to be using that formula in 9th grade. All right. And then finally, now you're done. Okay, the chapter challenge. So if you look at the pacing guide, there's a lot of questions they give you for each lesson of how to relate what they did in the lesson and looking forward to the actual challenge. So they should hopefully, been thinking about this and writing some stuff down as they go along. And you could even assign that as homework if you don't have time in class. And most of this, hopefully, if they've been thinking about and working on answering those questions a little bit as they go along, then most of this should have been done as homework or done ahead of time. So it shouldn't take that long for them to put this all together, in their paper for their track and field manual. Okay, so you shouldn't have to have so much class time with this to get this done. You could give it as homework actually for them to complete it. Maybe you could do rough final drafts. Up to you how picky you want to get with that part. But of course, I always say follow up with a review of these concepts: distance, time, displacement, speed, velocity, the motion graphs, acceleration. These are the big things you covered, okay? And I like to use MCAS questions I pull off online from the DOE website, linked on the Weebly, like I showed you way back in those videos, and give a traditional test because they're going to have to answer questions like that on the MCAS, at the end of the year. So I like to give them some practice ahead of time with this regular assessment. So they get their chapter challenge, part of their assessment grade, and then a traditional test. Because as I said before, we're still testing these kids, unfortunately. So, let's give them some practice so they can do well. So there you have it. And we'll take a look at what's coming up next in our next unit in physics.